information, certain, I'm sorry, yeah. So satellites are some things, which goes around the celestial bodies for a purpose, to collect information and to send us back, right? Now these satellites, in fact, again, all of us would know here, the first satellite was launched in 1967 um, by Russia, right? And for October 4th, it completed so many years. So it's wonderful that within these span of years, with that one first mission of sending our first satellite to space, till today, what all we have done with the help of satellites, we've literally explored every part of earth. That is first thing. We've gone to moon, we've explored Mars as well, and so many satellites have gone to other planets, and there are few satellites which have literally crossed our solar system. We have got so much of information about our solar system, which is, again, I think our scientists and engineers felt like it is not enough. Now we are working on something, knowing about what's out there outside our solar system as well. So the technology development is going on in such a way that you start exploring, the asteroids. I mean, the missions have been like to go land on an asteroid, like on a moving asteroid. We've done that. That's how the technology has, you know been growing, or, like, let's say, making advancements. So if we have to send these satellites to space out there, to different locations, be it just orbit the Earth, or send it to Moon or Mars, which are so away, and then we've also sent a lot of missions to Sun, like to study about the Sun, right? So these missions keep happening, and for these missions to send these satellites to certain location out there in space, we again need another technology. And that's nothing but launch vehicles, right? Those are nothing but our rockets. So rockets have been very instrumental, or been there from a long time, I can say. Actually, if we start reading about the history of rockets, we hear that these rockets were long back used for war purpose. I mean, it started in Greeks and Chinese. Even in India, we have some proofs of our Tipu Sultan using these rocket technology for war purpose. So rockets, from getting used for war purpose, to fight, to send things faster, that thought to a thought where it could be used to send things to space. Again, I mean, I always stress upon those ideas which people would have come up with, because that is what we always tell students. You must always think a little differently, to just see that wonders that could happen. So these rockets have helped, to put in satellites in space. Again, rockets, as I said, were used for war, or that was a long back, all right. But again, we started using it in terms of missiles. We all must be knowing about these missiles, which we again use in our modern technology war, or modern wars, I can say, wherein these rockets were used in a way that they could literally go so far with so high speed. Again, a thought was, it came out that if we are using missiles to send it, like to destroy something which is very far away, so specific location, now why can't we send it to space, right? Like, why can't we use it for launching, or to explore? That's again a wonderful thought. People have got at that time, and we literally put this experiment inside a rocket, when we use the same missile technology. Instead of just landing back on Earth, we sent it to space, right? So again, as I said, these two are very important factor in the whole space domain. One, satellites to explore what is out there, to conduct experiments, to do the research, to send us back. in fact, if we want the satellite to be in space, we need a rocket. So like a series of wonderful rockets have come up since then. Every country, every space agency, nowadays every startup which are working in this launch vehicle segment are coming up with trending technologies to be that best rockets, or to be that powerful rockets, or to be that economic rocket, like let's say, till a few years back, we would have seen every time we have to launch a satellite, we used to make build a rocket, wherein this rocket would just take a satellite to space and it just falls down. There's no use of it. Again, a thought of Elon Musk to bring it back safely, and the fact here is to prove it. He has done an amazing job, right? We all have seen SpaceX rockets. I will show a few pictures at the end, but yeah, this SpaceX bringing the rocket back and like just refuel it, do some small modifications if something went wrong, and launch it back again. That has become more like, economic, I can say, and saving the resources in one way. So this is about satellites and rockets, and things. Now, coming back to the topic of electric propulsion, I know all of you must be waiting why is she talking about space, but yeah, I wanted to like give an overview of what space is and the technology. So coming to electric propulsion, I'm pretty sure all of you here are attending electric propulsion series of talks which are used in vehicles and everything. Coming to space, it is slight different, right? Because even any kind of propulsion system compared to space propulsion system, they are like so different. Because the fact that we need to consider, there is no oxygen in space. You have to design a whole new system which works in space without oxygen. I mean, you'll have to carry our own, we'll have to carry our own oxygen, right? So this is our propulsion system in space. That's what was used long back. Like, we have something called um, solid solid propulsion system, or we have chemical, the liquid propulsion system, and then we also have hybrid, wherein these are the different type of propulsion system we use it in our rockets. Now, coming to satellites, what can we use? Because okay, the fact I wanted to tell you all here is, now we also take certain amount of fuel, or there is a propulsion system within a satellite. There is the need. You might be like, Nikita, you just said satellite is something that will keep moving, for which it doesn't need fuel, because it just goes in there because of its momentum and everything. It would just keep orbiting. Why would we need fuel? I'll just tell you why would we need propulsion system, first of all, in our satellites. I already said about rockets, for which if it has to move, propulsion system is important. So I'm going to go to the satellites now. We all know that the satellites are doing experiments out there, are always observing or collecting some information which they have to send it back. But the fact here is, the satellites might be looking at one point, but if you look at a longer duration, they move in a very minute way. So if you look at 1 year of duration, the satellite would have moved, or would have changed its direction of observation in a large quantity, if you look at it in 1 year way. But if you want your satellite to look into particular, a particular location only, or particular direction only, then there's always a need of correcting it. Like, for example, you want your satellite to keep seeing India, but a satellite, like after few after few months or something, because of all the solar radiation, and even sometimes our space debris hit the satellite, which is very minute change in the angle would happen. Those minute change will kind of affect a lot of observation change in our satellites. right? So for those correction systems, we need propulsion system. Similarly, if we want our satellite to be in one particular orbit, and suddenly you decided, no, I want my satellite to go into next orbit, so I have to change the orbit. There again, we use propulsion system, right? Then sometimes you would be looking at one country, and some other country requests you to give some data of their country, like for a longer time. There is possibility that you can, like shift the satellite focus towards one particular region and get that information. So shifting that focus again is propulsion needed. Now, like, I'll give you one more example. There's one satellite, there's another satellite, and for some reason, actually this should not happen, but it happens that these two satellites might be in the same orbit, or like they are crossing their path. If they're crossing their path, there is a possibility of them colliding, where we don't want to collide because the loss is huge. So what we will have to do, we'll have to either change this satellite, the path, or either satellite A's path, A or B. We got to change one of its path. Then again, a propulsion system is required where you change the path of the satellite, wherein one keeps going in its same direction, the other one changes a little bit so that they don't collide, right? So these are just few examples that I gave where we need propulsion system in our rocket, in our satellites, or we call it as spacecrafts also. So what kind of propulsion system do we use in these satellites becomes again very important, right? Like in the satellites, we most of the time use liquid. I mean, that's how it started off, liquid propulsion system. And then coming back to, I'm sorry, 1 second. Did someone turn off my video by any chance?
Yeah, please continue. You can.
Yeah, I'm sorry for that. Cool. As I was telling you, these spacecrafts need a propulsion system, and from the beginning, we've been using liquid propulsion system, which is easy, which is safe, because solid is something that is not considered safe, because solid, once you start burning it, until the fuel gets over, you can't stop it, right? So that's why we use liquid, because it's an advantage of, you can use whenever you want, you can stop it, things like that. So liquid propulsion system is what was like started. But then there is where now our topic comes into picture: electric propulsion system, right? So we started working on this whole new idea of ion thrusters, right? Ion thrusters, or ionic propulsion, I can say, which we started using it instead of liquid propulsion system. Not in all satellite, but in few satellites, right? So the reason is electric propulsion comes with its own advantages and everything, compared to our compared to our liquid propulsion system. So Sujay will talk a little about the electric propulsion system, the ion thrusters and things. But just to give you a heads up, he might cover it up. But then just want to tell you all that in India there is a startup which is working on this electronic propulsion system, not electronic, sorry, ion thrusters, electric propulsion in space, right? So the company's name is called as Bellatrix Aerospace. You all can explore more if anyone is interested. They've been doing amazing work. In fact, they delivered this whole system to ISRO, and ISRO launched few satellites with their ionic propulsion system. So I can say that it is there in action. We've been using it, and it's really good. Specifications will be shared by Sujay. Even I'll share it a little later. Just adding one more point from my end before I hand it over to Sujay is that the electric propulsion in rockets. Is it possible or not? Right? Now it is not there. Like today, do we have any rockets using electric propulsion? No. The answer is no, because it's a huge thing. Like, because we need tons, or like let's say thousands of kilo thrusts, newtons of thrust to go to space, and which is not possible with our electronic propulsion system or electric propulsion system. So today we don't have in rockets, but like most of them say it's a like a theory, science fiction theory, something like that. I mean, which could be made possible. That is one of the opportunity that I can say in the whole space domain. But yeah, we have in satellites and not in rockets. So I would now leave it to Sujay to take it further. Yeah. So Sujay, will you jump from there? Okay, I will. Great. So we just give us 1 minute to shift. I mean, he will speak. So stay, all of us, please stay.
Hi, good morning, everyone. My name is Sujay. So I'll just quickly run through what electric propulsion is and how it works, some of its history. I'm not going to go too much into history. I'm not like that big of a history buff, so I'm not going to talk a lot of history. And towards the end, we can probably ask some, like, answer some questions if you have, and how it works and what will be the future possibilities and things. So let me just quickly share my screen. I think it will be easy to tell the story when we have some images on the screen. So let me quickly share my screen. Okay, I hope you guys can see my screen. Okay, so these are the few questions what we are going to answer today. So as I said, why electric propulsion, or what is electric propulsion? How to start off with, we will talk how a propulsion system works. And I'm not going to go too much into history, just one line of history where it started and how it is going on now. Those are the few things which are going to which I'm going to talk, because this is a vast topic, and the time we have is like limited. I'm going to just cover a few things which are important and some interesting facts, and that is how we will take it. And last towards the end, we will probably can talk a bit more in depth. If you have any questions, or if you want to talk about anything in specific, we can do that. Okay, so to start with, let's see what is a propulsion is. It basically, when we say propulsion, it comes, what comes to our mind is rockets. So propulsion basically means moving something, and how we do it in space is using rockets. Generally, what we've been using from the last few years, and currently what is being used now, is something called chemical propulsion. As the name suggests, it's basically two sets of chemicals. So to produce thrust, right? And we need basically burn something and exhaust a gas out. So basically Newton's third law applies here, and it pushes the rocket, all the satellite which attached to it moves forward. So how it happens, we generally use two types of rockets in the space industry in general. One is a liquid rocket engine. That is a cutout what you're seeing here. In a liquid rocket engine, you will have a fuel, you will have an oxidizer, and it will go to a rocket engine, where inside a combustion chamber it will burn, and it will go through an exhaust or a nozzle, and it will produce thrust. The same thing happens in your solid rockets also. What happens is, the red part you're seeing here is basically the fuel, and it'll be inside a casing where it will be burnt, basically the oxidizer and fuel is mixed together, and it will be in a solid form. In a liquid rocket engine, both the parts will be liquid form. And there is one more type of engine which is called hybrid. We don't generally use them in space. They are mostly used right now in your amateur space, like, or hobby rocketry. We generally use them. Also, an interesting fact is Virgin Galactic uses them. It's called hybrid engines. They have liquid and solid. So their oxidizer will be solid, and the fuel will be liquid. Right. So those are the three types of engine what we used to have in space industry. Now the thing is changing, and with the current development in technology, we have something called electric propulsion. So that is what our topic for today is. So we are going to just talk about electric propulsion here, and what is the future scope, why is it so different, how is it improving the space industry, so sorry, space industry, or how is it better than whatever I was talking about previously, and what are the best, like what is the better thing about it, what is something which is not great about electric thrusters. So those are the few things what I'm going to talk about. Now, as Nikita was mentioning, electric propulsion is basically used now. It's used on satellites. We don't have rockets which is built of electric propulsion. It is basically for satellites and spacecraft. The first reason why that is because these electric thrusters produce very low amount of thrust. Okay, so rocket engines or chemical rockets produce large amount of thrust. Like it will be in tons, a lot of thrust it will be producing, and in electric thrusters they will be producing in millinewtons, right? And in your large rockets it will be producing in kilonewtons. So that is one of the reasons why we use in space, because in space to move around you don't need a lot of force, and these these engines producing very less amount of thrust, but you can fire it for a longer duration. Okay, so these are few types of electric thrusters. So you have two types or three types, you can say. One is electrostatic, where we have ion thrusters and Hall effect thrusters, and then we have electrothermal, where we have arc jet, and then we have electromagnetic, like basically magnetoplasma, and a lot of different engines are there in electromagnetic thrusters. So I'm just going to cover only very few because of the time duration. Okay, so the main advantage what we get out of electric thrusters is something called high specific impulse. So in general, your specific impulse for chemical engines are somewhere in the neighborhood of 500-ish. That is what the theoretical maximum of your chemical engines. Whereas in when you compare it with that, electric thrusters will have very high amount of specific impulse. So specific impulse means it's basically a measurement of your what do you say, how better it can do, or how better it can perform comparatively with the given amount of your fuel and oxidizer given, right? So, and this is one of the first ever electric thrusters to be produced. Okay, so this is one of the first electric thrusters to be produced. So it worked in very simple way. It was built in Russia. Okay, so you can see it was built in Gas Dynamic Laboratory in Leningrad, which is in Russia, or back in then USSR. So this was a time when they were trying to produce a lot of different types of rocket engines because that there was Cold War which was happening, and they wanted to build better and better and better devices. So they try to develop electric thrusters, they try to develop nuclear drives. So basically what they were trying to do is build a lot of improvements over the current rocket engine and build a better efficient engine. And that is how we came to electric thrusters. So what they did was very simple. They vaporized the materials inside using electricity, right? And it produced a better output when you compare it to your conventional rocket engines. So that is how they started off, and we are improving upon all these experiments which was done back then. And when you compare it with nuclear engines, so nuclear engines are also something which is producing very high impulse, specific impulse, but these are comparatively or far safer than the nuclear engine, because the exhaust which is created by the nuclear or the nuclear powered rockets are radioactive. So you don't really want to be near it, or you don't want your astronauts to be near it. So these are basically safer in a comparative way. That's why they pushed across and started developing electric thrusters. Okay, so one of the interesting things or interesting names or you generally hear when you talk about electric propulsions are ion thrusters. An ion thruster basically creates, or it's all ions which is pushed out of the rocket, sorry, the engine, instead of your gas going out. So that is how the name came along. So ions are basically positively charged, and what happens is there are gases inside the thrust chamber which will be ionized using the electricity around it. So I have a small diagram you can actually see here. So if you see here on the center, there is a tube. So let me just draw here. Okay. So you can see here, there is a small tube in the center, which will be pushing out the fuel, all the gases. And once it is hitting on the sides, what happens is the electrons are stripped out, and these are pushed out. Like these ions are pushed out because of the electric field through the exhaust. So which produces, again, as I said, millinewtons of thrust. That is how an ion thruster produces thrust. So you can see here again. So you can see here there are filters which will capture everything. Also, we can use this to control the amount of ions which are going out. So that is how you generate thrust. And this will be in millinewtons. And what you do is you leave it on for a longer duration of time. And when you leave it for a longer duration of time, the momentum it builds up, and that is how you increase your delta V or the change in velocity. It's basically that is how your satellites or the spacecraft will achieve great faster speed, right? Okay. So next, let's go next. Next is another thruster called Hall effect thrusters. A Hall effect thruster is basically more or less the similar way, just that we use magnetic fields, and then we will push them out. It's more or less the same way. So you can see here, we push out xenon gas, and we ionize it and then push it out with magnetic fields. So okay, so am I still audible?
Yes.
Okay, great. So okay, awesome. So let's go to the next one. The next type of thrusters again is called hydrazine arc jet. So it basically means you are using hydrazine fuel, and you are accelerating it again using an electric field. So which greatly improves your efficiency, greatly improves your specific impulse, because of it's not just the exhaust from the hydrazine fuel, it is also the magnetic fields which are affecting that particular output. Okay, so then we have next. Okay, so you can see different how an actual arc jet thruster looks like in real life. So it may look very complicated, but there is a lot of development and a lot of improvement that still can happen on these thrusters. There are a lot of opportunities to work, but hydrazine is a dangerous substance. It causes a lot of corrosion. It causes a lot of it's basically harmful for humans. But you can actually get a lot of specific impulse from hydrazine. Just hydrazine are also used in generally rocket engines. If you have seen the rocket launches of China, and you will generally see orange plume. That is because of the hydrazine fuel which is burning in the rocket engine. So they generally use it as one of the chemical rocket engines in Chinese rockets. They also use it in Russian. Basically, Chinese rockets are a derivation of Russian rockets, you can say. So they also use it in proton rocket in Russia. Even in India, we use it. We use hydrazine thrusters for satellite propulsion. But it is very bad for environment, and it is also harmful for human. It's actually a carcinogenic, which means it will cause cancer in the future. So it is one of the dangerous substance, but it actually produces a lot of thrust. Then we have plasma thrusters. It basically, as the name suggests, it is plasma which is being pushed out instead of your ions. It is the plasma or the hot gases which are being pushed out using the magnetic fields or the electric fields. So you can see in this particular image, the plasma is being pushed out using this electric fields. Okay, so to start off with, how or where do we use these kind of thrusters? So you generally know that, okay, when you are going to interplanetary missions, or you are going to you are planning to go to like a long distance travel, like you're going to Mars, you're going to Jupiter, Saturn, or you're going to explore an asteroid. So these are the places where you can generally use electric propulsion systems in the future, because it can cut down on the amount of fuel you need. Okay, so if you take in the case of Mangalyaan, we launched a satellite into Mars, and actual amount of the scientific payload which could carry on that particular mission was just 15 kgs, because most of that rest of the 1,000 odd kgs of the satellite was taken up by the structure and the propulsion system, and almost 80 to 90 percentage of that the satellite was just the fuel. We need that much of fuel for orientation. We need for decelerating in the Mars atmosphere and getting into the right orbit, changing the orbit. We need fuel for all these things. These all can be improved, or these can be done by a bit of planning and using electric propulsion systems. So that is why one of the important future in space is electric propulsion, right? So if you are exploring Mars, you can basically cut down on times of reaching Mars. It generally takes it approximately 6 months to reach Mars, and you can actually cut down on reaching time by like 3 months, because you can leave your electric propulsion on for a longer duration. Like your chemical engines, you can leave it on for a longer duration of time, and once you have that much of time in your propulsion, you are generating that much of thrust. You are generating it's actually cumulative thrust, so it will produce more delta V compared to you leaving on your rocket engine for a couple of seconds and leaving it off. So using that, you can cut down on the time. Also exploring different asteroids. So suppose in the future, one of the major improvement that is going to happen is something called mining, or in space mining, basically mining things in space, bringing it back to Earth, or building structures in space itself. So that is one of the important thing which is going to happen. And for that, these kind of technologies are very important, because if imagine you are taking a rocket. So if you have taking that much of fuel, just the fuel that much, you're cutting down on the amount of things you can take to space or bring it back. So if we are having considerably smaller thrusters and limited amount of fuel which is required when the case of your electric thrusters, you can carry around more cargo when you compare it with its chemical counterparts. And also there are a possibility of using inner orbits. As Nikita was mentioning, there are drift which happen in space. So this is something which is happening right now. ISRO, I think they are planning to launch another satellite I think they actually launched one satellite and they are going to launch one more satellite now with electric propulsion into a geostationary orbit to do something called station keeping. So as the same case I was mentioning before with your Mangalyaan. So if you have seen the communication satellites, one of the biggest ever communication satellites we have launched is GSAT, and that also 90% of these satellites are the fuel, right? And that was around for GSAT 1, like GSAT 5 was around 5 tons or something, and we had to go to the other launch provider to launch it, even though we have rockets. That is because it was too heavy for our rockets. Using electric propulsion system, we can cut down on the amount of fuel required, and we can launch it from our country itself, or it is possible to carry more transponders. Also, we can develop systems for lower Earth orbit satellites, where we can use it for station keeping, collision avoidance, and a lot of different things we can use these satellites. I mean, next important part is the CubeSat. Now, if you are interested in your students working on these propulsion systems or electric propulsion system, one of the major opportunity will come when it comes to CubeSat propulsion or small satellite propulsion. It is all in rage that there is a lot of opportunities in CubeSats, right? There's a lot of companies which are building CubeSats. There are a lot of companies which are launching CubeSat constellation. Like you have Elon Musk launching, Starlink. There is Planet Labs, which, if you remember, a couple of years back, launched 108 satellites in an Indian rocket. So those kind of companies are using this CubeSat platform and or smallsat platforms, which can be or which will have to use electric propulsion. In fact, the Starlink satellites actually use xenon propulsion system in their orientation and collision avoidance thrusters. Now, the same thing will happen in the future in the CubeSat industry, where we will need miniaturized propulsion systems, and this is one of the best thing you can do. Like electric propulsion in CubeSat is going to be the biggest thing in the coming next 1 decade or 2 decades. That is going to be the next big thing which is available, because a lot of people are building rockets, but not a lot of people are building the thrusters for satellites. There are very limited number of companies in the world actually building or developing technologies as such, whereas in there are 100 odd companies who are developing rockets for launching the satellites. We don't know who all will be successful, but in this particular area of in space propulsion, there is a lot of possibilities, not a lot of players. There is still place for new players to join in and develop new technologies, develop new systems in place. So talking about all that in the future, I'm going to end my presentation here. I think we can probably have like a 5 minutes or 10 minutes talk, or depending on what time we have, about if you have anything you want to ask, or if you want to add any other points, you can probably add in now. Thank you.
Yeah. Thanks for Sujay sir for wonderful presentation. So we still have time till 1 o'clock. If you have a presentation till 1, you can continue, or else we can go for Q&A.
As I said in the very beginning, we will be happy to take some questions, because
Sure,
we always want to talk to people, rather than we just talking. So yeah.
Yeah.
So
Okay.
I have a question. Can I jump in?
Yeah, please, sir.
Yeah, I'm Shiva from Germany. Actually, I'm
Oh,
talking.
great.
I'm talking to some guys in Berlin who's happened to be a plasma physicist who's into a lot of experiments. I agree that you're talking about like some millinewtons of thrust. I agree with that. It's still in the research and R&D phase. The fundamental problem, actually, you also didn't mention, we're not talking about millinewtons of thrust for kilowatts of power. I'm talking about megawatts and gigawatts of power to get some meaningful thrust. Megawatts and gigawatts sounds, it's too much actually. Where do you get this power from? I mean, it sounds great. You can accumulate the thrust, and it's an accumulated thrust. You keep on adding it, and you can keep it on for a longer time, and you can get to higher speeds. But where do you get this megawatts and gigawatts of power from?
Okay, so generally, these type of engine, as I was mentioning, we will be using it, or the possibility of using these will be for a longer duration mission, like into a Mars or into an asteroid. So generally, what they can do is you can use solar panels. I don't think you need gigawatts of power. Generally, these thrusters can work in kilowatts. And these can be easily generated with solar panels, which is on board. The efficiency of the systems are being improved. Again, that is what my original point was. It is not, something which is right now, which is all in rage. Like they are still developing new technologies. See, the thing is, nothing comes out like how it is going to be or how it is going to be in the final product. Just take in the case of your mobile phone, right? When they started off, it was just a transistor, and now there are billions of transistors inside my mobile phone. So there is always an opportunity to improve and build upon without someone doing or without putting an effort into developing these technologies or investing in this. There is no way that these technologies will just evolve just like that. So people has to put their minds and thoughts and put their time and effort building and developing these technologies. That is one of the major challenges. Same thing Elon Musk did with electric car. You know how the electric car was and how it is now. Basically, they can race a Ferrari and they can still win. It was not the case before. Right? You would have not even thought of buying an electric car if it was not for Tesla. It was not that there was no electric car which was available. There were a lot of electric cars which are, a lot, but there are still electric cars which are available, but you never thought until Tesla decided, okay, you know what, I need to solve this problem and let me build a better car than everyone else. So it is possible that the possibilities are there, just that you need to find a solution which is already out there, just that it is not existing right now. But doesn't mean that we should not develop these technologies. That's it. That is what my thought process is when it comes to these kind of technologies.
Yeah, I agree with you. Like it's a long way to go, but just want to understand like where we are right now. I mean, it's like how many kilowatts of power you need to generate some X number of millinewtons of thrust. Question, sorry, maybe I made it indirectly in a longer way. Yeah.
Okay, so I don't have a specific numbers, and it totally depends on different engines have different types of requirement. But as far as I know, there are already technology demonstrators which are on satellites, and I was mentioning this in between my presentation. ISRO had already launched one of the demonstration satellites, a geostationary satellite. Also, Nikita was mentioning about Bellatrix Aerospace. They had already launched one of the demonstration thrusters. They're ready to if everything goes right, they are also ready to launch one of the versions which can launch on a CubeSat. CubeSat generally produce what 100 watts of power. They're ready to launch thrusters which can work on that. Like it's actually not 100 watts. It will be quite less than that. It depends on what kind of output you need. If you are looking for specific numbers, I can probably check with my friends who are working on that particular industry and get back to you. Or probably if you are really interested, I can probably connect you to them, and you can talk to them and understand in depth if you are interested in it.
Thank you very much. Yeah.
Dear participants, please, please ask.
Do we have any questions?
Participants, now you can ask if you have any query regarding the presentation.
Or in general in space.
Space propulsion.
Yeah, it doesn't have to be just about space or space propulsion. We can generally talk about your satellites, or you can talk about different systems in space, or anything as such. It doesn't matter.
Yes.
Oh, sorry. If you don't have any questions, then as I said, feel free to ask anything like to space. The fact is, we wanted to spend some time talking to you all. So that's the reason we worked on very short and crisp information about the propulsion system.
Yeah. So fine. Since we have our audience as faculty members from various institutes and also research scholars who are all working on this electric vehicle space, can you briefly tell about how SSCRD is contributing towards developing the resource that is required by our country, or in general, like how the faculty members can take this presentation to the students and how it will be helpful for them? Can you just shed some light on that?
Yeah, I'd be very happy to answer that. Since we have most of the audience here as professors, right? It becomes the thing is, space has become something very trending, I can say, or something that is advancing in such a high rate, or that. I mean, those who are in space, we can tell you this because every day we hear one or the other news. Like, I'm pretty sure all of you would have heard in past 2 months how trending the space tourism was, right? Like, there were 3 companies and all 3 companies exhibited their space tourism capabilities. There again, the propulsion system is included in it, right? But it's not with electric, but propulsion system is involved in it, because we're talking about going to space and come back. So that's space tourism. And then just 2 days back also, there was this news wherein the astronauts were taken to space to shoot a movie. There was an actress and director. It was from Russia. So they started using space for entertainment again, right? So space is something which is like doing one or the other things always, So with all these global advancements that's happening, most of our students are now getting interested or getting, have with just this thought of, okay, space is something good. Do we have an opportunity, right? This is what everyone is asking or exploring. So probably you all can tell again the same thing, how space technology is, and like as we said today, and how important it is going to be. Like how Sujay said, if we are going to Mars, which is the future again, so many things are important over there. Like he would have just spoken about the technology aspect of it. Now let me ask you, if we go there, are we ready to go and live in the places? Like we can't stay in the houses like these with doors and windows open, right? So we got to come up with a whole new architecture. What about food? How do we handle the food over there? Probably for first 2 years we will take food, but what happens after that? We need to keep taking food that is like not that good. So we might need to probably think of a way to start growing food there, or those are the things that we want the current generation to start working on in order to make that possible in the future, right? So these are things which are like really, like I can say the opportunities. Another major opportunity that most of them have in the space industry is the fact that space can solve so many problems. We all know that weather was one of the major problem long back, and today we will actually get to know what is the weather in next 15 days, like today itself, and they're almost accurate. I mean, there's some percentage of inaccuracy, but that's fine. We actually get to know if there's any cyclones coming up at least 3-4 days before, where we can start taking measures and precautionary measures and stuff. So talking about, the problems that we have today are going to be the major problems in the future, that is like climate, and then the our urbanization, water problem. All these problems has a space solution. I mean, could be found. And it becomes so important that the student thinks of innovative solutions, particularly space solutions, to solve these problems here on Earth. Because until some time back, we only spoke about like outside the Earth, but then there is a need of space technology for the problems that we're facing here on Earth as well. And that's where we need to encourage our the younger generation or the students to work on these problems, to have a sustainable life here back on Earth, right? This is something which is very important, which you all can tell that if anyone is interested in space and they are interested in all their good innovations, then just tell them that space solutions are something that they can think of. Now, coming to us, what we do, we both being space enthusiasts, our goal was to tell everyone what space is. That was our first goal, because while we were studying, a lot of our friends like literally thought that there were few of our friends who were doing aeronautical engineering, thinking that they would become pilot at the end of 4th year. There were a lot of our friends, juniors and seniors, they took aerospace thinking that they would study about stars and planets, where what they studied was totally different. So we felt like there is a need for us to start telling them what is space. If you like so and so, what domain you need to take it up in the in the education way and all that. So for that, we were like, okay, college students, they've already got into it. We can probably help them to get it corrected in their higher education level, but not right now. So that is when we again started focusing on the right age of people, that is, students in their high schools who would be dreaming of, I need to become this, I need to become this. So we wanted to start telling to those students what space is and different domains, to an extent that we started introducing very new topics here in India, that's like space medicine, space law, space architecture, which was not at all even till date in India, it's just scientist and engineer. That's the two things that anyone would think of. But then there are so many other opportunities out there which we wanted to tell students, create that awareness through our programs. So that is what the role that we took up when we're trying to do that with SSCRD. For sure, we need all of your support. The thing is, we probably could reach out to 100 students, but with 100 teachers, probably we can reach out to 1,000 students. So that's where I'm pretty sure all of you could help. If you come across anyone who needs support, who needs guidance in this space, please suggest them to reach out to us, because we are here literally spending our life just to tell what it is and try to help them. So yeah, that's about us.
Sure. Thank you. I really appreciate the objective of SSCRD. And from my side, I would like to suggest that you should include the technical institutes, higher educational institutes in your pursuit to make space accessible for everyone. and I think that would serve the purpose of, I identified the gap that we are having here. You're addressing school students. That is very good. They will get introduced in the beginning itself. Also, I think you need help from the higher educational institutions where the courses are there in aeronautics, aerospace, and electrical. So there might be a collaboration between these organizations, and definitely, I hope you will serve the objective very good in the near future. And we have very good, set of audience here who are working in various domains, right? And definitely, all of them can take some lessons from this particular session to their students and discuss some new project ideas. And if they need any help, they can definitely contact you guys. Okay, good.
Yeah, thank you so much for the invitation. As you said, though we focused on school students, we never forgot our college students. Now the goal has been to empower those students who are in their undergraduation, to
Yes.
train them on how to do the research, how to work on a project. And in fact, we've been working on one of the project wherein we would, train a student in such a way that, or we would, prepare the students in such a way that they're ready to be hired by space startups, because we are in this space startups community, and we know all these space startups out there. They're all growing every day. Every startup out there who are like doing amazing work and progressing, and they are looking at expanding their team. They need
Yes.
talents, and we have been training these students in this domain. So now we want to bridge that gap. Startups need talent, and we have been creating talent. So we want to
Yes.
combine. So that's something that we're working on. And of course, we need all your help, not just your institutions or every other institutions out there and all the professors here. We need your support. We're working on this idea. It's almost done. We will reach out to other sir, and probably other sir who can put us in touch with all the other universities, and like if it helps students, then that's what we want. So yeah, thank you so much again for this opportunity to
Yeah.
talk to you all.
Great,
Actually,
great.
I just want to add something here. Actually, I just figured out really
Sure.
what you're doing. And I was not fully aware of what you guys are doing. It's really great. Like you are enlightening students at a very young age. This opens up a lot of opportunities. The brainwash what is being done, because I know I've studied in India. The kind of brainwash what is being done and what is possible by physics or science is pretty narrow and very limited. Actually, it doesn't give the what is possible beyond the textbooks. Actually, to be honest with you, like there are so many things which are not taught in the books, which opens up a lot of new domains and possibilities. For example, you said like for sustainability, right? So we are being taught that the energy is limited. Energy can be neither created nor destroyed. That all is true, but we don't have to run after fossil fuels to generate fuel. So kind of crap we've been taught in the school and brainwashed. There's so much of abundant energy all around us, like even in the open space where you have energy till minus absolute zero, like minus 273 degrees centigrade. Even empty space has a lot of energy. Like this has been not taught. Actually, this is really the fundamental thing. I would recommend that you guys teach these young students what is a homopolar motor and what is a homopolar generator. This is very easy to show you. All you need is just one battery on one magnet, one wire. That's it. And there are tons and tons of possibilities of getting a lot of energy, an easy way to create because you also need flywheels or gyroscopes to get orientation in the space, right? So that homopolar motor will teach a lot, and this opens up a lot of possibilities, because I know there's one guy in India also recently who died, who did a lot of work, and also the N machines. There's a lot of possibilities, but this technology has been suppressed. If you can teach those kids, they'll come up with great solutions and ideas. It should solve a lot of energy problems, not only on Earth, and it will also solve electric propulsion for rockets in the space. Actually, you need to bring guys who think out of the box. Actually, this would really help. Actually, what you guys are doing is really amazing and great. Thanks a lot for your contributions here. I would
Thank
say.
you very much. Thank you very much. We would be very happy to get connected to all of you. We would just put down our LinkedIn files here, so feel free to get in touch with us.
Sure, sure. So, Shiva sir, thanks for your insightful comments on the session. Right. So we have in the chat box the LinkedIn profile for Nikita ma'am. So participants, please get in touch with them for any project related to space and electric propulsion. So we have one more question from Dr. Anand Raman sir. So it's technical. So I will just quickly read it out. How the plasma will hold in the propulsion chamber? So this is, I think, a very specific question. If you can answer that.
Okay. How the plasma will hold in the propulsion? Okay. I'm not exactly sure what was the question like, or why did you ask that specific question? I'll just quickly show you that particular image. If you remember, that plasma is generated and it is pushed out using the either that electric field or the magnetic field. It is not stored over there. It is generated, like the plasma is created and it is pushed out. It's not that we keep it there. It's same like, see, it's basically the same as your rocket engine. It is not it is not like entirely different. It basically generates and it pushes out. When it is required at that point of time is when it generates. So we don't really need to store that particular plasma in that field or in any point of time.
No, just have to add some point to this. The thing is, as the Dr. Shiva Chanapati has pointed there, there was the need of a large temperature in order to have propulsion in the meaning of that. So therefore, what my concept here is, if you can generate plasma inside a system, so that can be made to provide some nuclear fusion technique, and energy can be developed, and that can improve the energy saving point of view. That's what I am feeling. Instead of pushing it out, if you can hold it with some magnetic mirror coils, in fact, so that can provide you some lot of energy, in fact, and it can push the things in a little bit higher energy in total. That's what my idea.
Okay, I understand. So there was, to tell you about this nuclear propulsion, I did briefly mention about nuclear propulsion in when I was giving, I was talking about the propulsion system in general. There was a lot of, discussion and debate about nuclear propulsion engines. It's just that when it compares, if it's a robotic spacecraft, they generally are safe. But when it comes to human-rated spacecraft, that is one of the reasons why there was not a lot of discussion which happened about nuclear propulsion. But if you remember the ArcJet, sorry.
No, please continue.
So it is possible to add something more to create more thrust, like how an ArcJet works. It is possible. If you are interested, or if you are thinking of developing that particular method forward, probably we can connect later on, and then we can discuss. And either I can just put you in touch with people who are having that much of expertise in that particular field. Probably I can do that for you.
Okay, thank you, Shell.
So from my side, just a quick question till the participants come up with the next question. So what is the status of Tesla's Roadster that was sent to space a couple of years back?
Okay, that's an interesting question. So as the orbit goes, it will be in something called as a heliocentric orbit. So it is going around the sun. So heliocentric means it is a orbit around the sun. Even though they were planning to go to or send it to Mars, it actually missed by a couple of hundreds of kilometers, and now it is orbiting the sun. So it will orbit there forever until there is a possibility in the future that there will be a pass or like it will go near Earth again in another maybe one or decade. It will come back again, but it will be definitely different color than what we actually sent it out.
Is it still in the original shape and size, or is there any degradation of the material? Or
So yeah, so when we were talking about space, it is vacuum, there is low temperatures, so there will be definitely degradation of material, the paint flakes. We don't really know how that particular paint on that roadster will react to that kind of temperature, because they were not designed for that kind of temperatures and the radiation and everything which was out there in space. So it is not going to be the same as what we originally sent out. It might look something of entirely different color with the next time when we see it. But I think it'll be an interesting thing to see when next time it comes around the Earth, how it will look like. Yeah, so there are like a lot of micrometeorites and a lot of debris in space. The possibility of hitting is very like very low, but there is also a possibility of some asteroids or some part of comet might go and hit it, and it will leave some scratches. That is also a possibility.
okay. Yeah, thanks. So any other query from other participants, please, you can unmute and ask.
Okay, so I want to add on one point where Nikita left out last, when she was talking about what we do. See, the whole idea of us is to connect students into space industry, because we have a mindset that space industry is something which general people can't just go in or develop things for. We want to change that mindset from all of the people. We have our students who are developing satellites. We have students who are using satellite data. When I say students, we are talking about high school students, not even university level students. So if it's possible by them, I'm sure it is definitely possible by an undergrad or postgrad students. So we want to break that, thing telling that space industry is only for those people who are working in ISRO or NASA. So we want to remove that stereotype. So if any one of your students are interested, or I would suggest you go push your students, because space is going to be the next big frontier in another 10 years. So we are always here to help to bridge that gap and connect you with the right people and the right, like when I started off, I never had any connections in the space industry. I had to literally build every single connection we have till now, right? And it is not easy. I spend a lot of time getting connected to different people, or us as an organization, it took us a lot of time. It doesn't need to be that difficult for the students. That is what the whole idea for us is. When they reach out to us, we will be more than happy to connect them with whomever they want, with that particular area of expertise. Right. So feel free to ask how do we can work together, or anything. You have any questions, feel free to ask us. I think we still have some more time left.
Yeah, and questions are keep coming to my mind, like, so I need to ask this. So, like we have SpaceX in US. So since you are into aerospace from long time, so what are the startups that are like that will be the future SpaceX in India?
Okay, so there are two major companies which are in that particular domain. One is Agnikul Cosmos in Chennai, and another one is Skyroot in Hyderabad. So they are the ones who are somewhere closer into developing a launch facility or launch systems or rockets basically. Those two companies are the ones who are really close to actually realizing that the, to tell the truth, their timeline seems to be a bit too close than what generally be comfortable with. They are aiming to launch somewhere in the next year. But in realistic sense, they should be ready in another 2 years to 3 years. We should see our own companies launching satellites into space.
All right. That's great to hear. Right. So, any more questions from the participants, please? You can ask. So it's been an interesting session.
Okay, so while everyone is thinking about the question, I want to just throw in a couple of other things which just came to my mind when you asked about the companies which are in rockets. Now, space industry, as in general, when we say space, only two things comes to your mind. One is rockets, and another is satellites. There are things way beyond, and generally people don't see. It may not be the hi-fi things of satellites and space or satellites and rockets. There are so many other opportunities which are there in upstream, like providing satellite components, providing systems, providing with different high accuracy material, like in India. So if you look at the rockets, ISRO launches rocket, but a lot of different subsystems inside these rockets are built by different companies. We don't generally see them. A lot of downstream activities, like
Yes.
using satellite data to plan out. There are a lot of different companies in that particular area now, like using satellite data to predict agriculture, using satellite data to see the ship movements, using satellite data to predict weather. A lot of different opportunities are there in the satellite space industry, apart from launching rockets or launching satellites. So this is one of the other things which I would stress upon all of you here. If when you're talking to your students who are interested in to going to space industry, ask them to also look at other opportunities as well, not just launching rockets or launching satellites. Look at other opportunities which are already there, which is already being developed. Agriculture is going to be another big thing which is going to happen in space. Mining is going to be another big thing which is going to happen in space. Like building, like if you remember a couple of years, like a couple of months back, actually, a startup in Chennai, they 3D printed an entire house. Those kind of technologies are something which we can use in space to develop habitats and things. So those are different opportunities which are out there, which generally people miss out. Ask them to also look out for those kind of things, not just starting a company which can build rockets, starting a company which launches satellite. I mean, the thing is, we generally see all of them every day telling that, what, my big idea is launching rockets. My big idea is building CubeSats. I mean, beyond that, there is a lot of scope. Let them explore that also. Ask them to explore, not just this, ask them to explore. So they will come up with a lot of interesting things which people would have not even thought of.
Yes, yes. Right. So when you talked about mining in space, so and since we are talking about electric vehicles, so is there any possibility that in space we get lithium ore? Or what are the minerals we are looking at when we talk about space mining?
See, whatever minerals or whatever materials which we are finding on Earth, except hydrocarbons generally, you can find all of those materials plus something which you don't generally find in Earth out there. We can find some exotic materials like helium-3 in space. So they are used in fusion reactors. Also, all the materials what you're seeing actually came from space. It's basically a remnants of star explosion, and these are the same materials which are there in other planets, moons, or asteroids, or comets. It's all the same. So yes, there are possibilities of finding it everywhere in universe.
Right. Okay. I think if there are no questions, we will end the session now. So I would like to thank Nikita and Sujay Sridhar sir for a wonderful session on the application of electric technology in space and giving us few examples like how it is possible to explore it in the future research. So thank you very much on behalf of all the participants and on behalf of MITE for sharing your wonderful experience.
Thank you so much for having us.
Thank you very much. It was wonderful talking to everyone.
Sure. Thank you. Thank you. So, dear participants, we will end the session now. By 2:30 in the afternoon, the question and answer session starts. That is the end term test. It will be for 1 hour. And then we will, by 3:30, we will start the valedictory function. So thank you all the participants for joining us. And again, I thank Nikita and Sujay sir for being part of this FDP. Thank you. And also, I would like to thank especially Shiva sir. He joined from Germany. Thanks, sir. Thanks for your insights. And yeah, I think we missed. We will have a photo session. Yes. All the participants, please switch on the camera. All right. Yes. Thank you. Thanks, participants. We'll meet at 3:30 and 2:30. I will send the link. The link will be active for 1 hour. So you can answer. All the questions would be MCQ type. Then from 3:30, we will join for valedictory function. Thank you all.